Hello everyone, hope you have a great lunch. I will quickly introduce myself. I'm Karim Sudki, security expert at Skudevsky IoT Labs. Our main, let's say, area of expertise is hardware attacks. We are doing glitch, EM, laser fault injections, as well as some side channels. And we are also doing most of the time security evaluation on IoT products. And back in 2021, the company decided to develop its own vehicle tracking solution. And they wanted to gain insights on what's the security maturity of some actors on the market. For me, it was just another day, another project. So the need for having car tracking is because if you look at the statistics in the USA, the motor vehicle thefts per 100,000 inhabitants is drawn in orange. As we can see, it's quite high, and as technology evolved, it slowly goes down until at some point it stays at the same level. And if we have a look on how much car is theft per year, per time, it means in 2015 that one vehicle is theft, is stolen every 45 seconds. So when your car is stolen, there is some pains. Basically, you need to find your car very, very quickly because you don't know where it is. So you need to contact law enforcement, insurance. Probably your car is already dismantled, and all of this costs money. So one solution, but I don't know if everybody will do it, is to apply some good paintings on your car. I would say the real solution is to put a chip in your car and know its location at any time, share its location with law enforcement for fast recovery. And all of this evolves in a market that it even allows you to track your teens when you take the car. In the US, you can drive at the age of 16, so you can geofence your car to know where, if it crosses a certain area. You can know if it crosses certain speed limits. And you can have a nice insurance discount, like 15% is pretty much, I would say. And there is also the dealers that sell you the car. They can provide you some recalls notice if there is a problem with the car. They can also ask you for an appointment. There are several other things, like you can know where the car is on the parking lot because they have a lot of space and don't know where the car is. So you have a whole monitoring solution for your cars, and you know every time where it is. So car trackers, there are many of them on the market. You can see most of them have screws to stay fixed on the car. Some of them have even ODB2 connector, so you can guess what can go wrong at this point. So for those who are not familiar with such solution, basically you put a device in your car, you fix it, and this device acquired the position with the GPS. And some of them have even Bluetooth or CAN bus. And all the events that they are collecting are sent to a cloud infrastructure via 4G network. And on the consumer side, what you have is basically an application that allows you to see where the car is and have all the notification with that. Some of them have even SMS fallback, which is quite interesting because when you lose internet connection, you can still have SMS coming in. So it's quite convenient if you lose the tracker, the connectivity with the tracker. In our case, we looked at a specific company, which is named Spyron. This company has 4 different products. They have a product for dealers, basically for you and me at the end, because it's in your car, so it will be beneficial for you. And they have things like trailer asset management, inventory management. This is more for an enterprise like DHL or such company. And they have a last product which fits inside the category where you can go in the garage and have financing by the garage itself. So you need as well some solution to track the car and to get your money back in case of non-payment, for instance. So here we had a look on the KAU low jack device. It was rebranded between when I did the research and the talk right now. They have also promoting their own cloud platform, which is called Inspire, which apparently have more than 3.5 million active subscribers, so it's quite huge. So the tracker itself, you can find it in a fuse box usually. It comes with a bunch of cable that we see on the right side. You can see on the specific wires that it steals power from the ODB2 as well. However, there is no or little interaction with the ODB2 itself. So when you have this device, the first thing to look is to gain information about the device, how it works, what it does. And for this, you can use the FCC ID. The FCC ID is basically a grant that you need to acquire to sell or import radio frequency devices on the US market. The label is usually located on the device itself, like this, and it's very convenient because you can find internal photos. So even without having the device physically, you can know what is inside and start to prepare basically if you want to attack such device. You have also user manuals, which can give you some insights on how it works, basically, what the device accepts. One good thing is that there are some sites that allows you also to query the manufacturer, which is quite convenient, and we will see later in the talk why. So for this specific device here, we have a fancy user manual with some, let's say, features. What we can see is that the device accepts remote updates over the air. It's using FTP, so okay, why not? It supports as well at 80 commands. So for those who are not those who doesn't know what is an 80 command, is basically a protocol that is used over a serial line to configure a modem. So they extended these commands. As we can see, the device support extended 80 commands, which are specific to this device itself. And we can even know a little bit about the report format, such as the report is simply a hex encoded binary stuff which is sent over the network. Now we saw before that we have a bunch of wires, so the red and black is quite easy to guess what it is. So power supply. We have a white one, which is for ignition sense, so to know whether the car is started or not. And we have a last wire, green wire, which seems to be a starter disable relay wire. So it goes into something. It can be present or not. By Googling a little bit more about the company and about the tracker, I was able to find this documentation. So I'm sorry because I couldn't find any better quality than this one. Also, I need to specify that on the left side, these circles and rectangles are in fact the car. So what we can see, what we can discover on this schematic is that in red you have upstream that what the device sends is sending to the cloud is in red, and what is going to the device is in yellow and green. It seems to be related to MQTT, but we can see that there is a lot of Lambda functions since it's based on AWS IoT. And so we have two parts, if I have to summarize. So we have the blue parts, which is internet-based connection, so normal IP connections. And we have a fallback in SMS as well. So from this, we already know where we want to go. So no Bluetooth, no CAN bus. We have a hardware, and we need to see the network aspects. I won't talk about the application nor the cloud because we are a hardware lab, so I didn't went that far, but maybe it's interesting to have a look as well. So for the hardware, if we are looking to what the device is, so the device is the size of the hand, basically. It's exposed with 16-pin connectors, and if we look at the wires that is used, there are like 4 wires only exposed and used at in the outside. So what does the other pins do? For this, we need to go deeper. Fortunately, the box is quite easy to pop. So here we can see on the left side you have the connector, so the image are synced. We have some unpopulated connectors, so test pads with markings. We have the GPS antenna in blue. We have the SIM card, which I found I had 2 devices in hand, so one was Verizon, the other one was Sprint. We have a space for a backup battery, which is optional. It depends the model. We have as well a microcontroller, which is in green on the right picture. A USB port. We have a Kectel BG96 module as well, and ST free access accelerometer. So when we have such things, we start by looking what is on the PCB basically. So by looking on the PCB, we can see some markings already. So I highlighted the ports of interest that I found on the device. We have seen there is many of them. Some of them are not used. Some of them are used. So for this, we need to check the voltages. So you see with the voltmeters what is the voltage. Basically measure takes lines, transmitting lines, to know if something is active on this interface. You can do the same for RX reception, because when you do that, you can know if somebody is another chip, for instance, is communicating over the same interface. So both lines will be up at a high level, let's say. So we wire the logic analyzer to the device and monitor signal as startup. And this is what we can observe. So basically on the green, we can see that there is a bunch of printings with the product version, EMI, binaries version, application version, IP, ports, fine. On the red one, we have some kind of weird serial communication, which doesn't look common. And we have as well on the blue, just a message that the application is ready. Good. So what can we do with those interfaces? Which is chipset drives the whole logic of the system, because it can be the MCU, but it can be also as well the Kectel BG96. So what we should do first is grab the firmware. Since we don't have access to the firmware because they are not public, we need to retrieve them back from the device itself. So I decided to have a look on the first one, which I know pretty well. The first one is an entry-level microcontroller from STM Macro. It has some peripherals. It's quite common to see those. Using the information that we have on the PCB, so on the other side, on what I show on the right side, we can see that there is already some markings. So looking at those markings, you can use a voltmeter to do a continuity test between the pins to know where they are routed, basically. Using that, we found that it's going to the microcontroller. The microcontroller, we look at the datasheet, and we can know that it's a single wire debug interface, which is used by the STM32 to program them, debug them, etc. So what we do then next is that we take a debug probe. We wire it to the device. So you have multiple choice. You can use the official ST-Link from STM Macro, but you can use as well the Hyderbus, which has a 2-wire mode, and you can use the ID code command to see if the device, you are on the device, and you can query it, basically. You can use also OpenACD. So OpenACD with the correct configuration, you will see that you will get in green the identification number of the CPU, and OpenSSD will listen on port 4444 for a telnet connection. And through this interface, you can basically interact with the debugger, and you can reset the chip, query for the memory, dump its content. So here, what we need to do is to connect to this port. We maintain the reset of the device so that it doesn't run the microcontroller, and then we dump the image. And here, what we can see is that there is no protection on this microcontroller. So it's already good. Next step, we fire Ghidra, we use Cortex little engine, we fill out the base address. We can use the system view description files to map the peripherals. We start to reverse engineer, and unfortunately, there is nothing in this firmware. So we will investigate the other one. So when we look at the other one, in fact, it's a Kectel BG96, which is a system on module. System on module means that there is various parts on top of a small PCB. And here we can see, if we remove the shield, that there is like 5 or 6 components. There is the main CPU, which is a Qualcomm ARM Cortex A7 LTE modem. We have a power module, RF amplifier, and some flash memory. So normally the program should be in the flash memory, so we'll just dump it. So to dump the flash, we unsolder the flash from the board. However, we cannot use a heat plate like we do usually, so you can use also a heat gun to do that. However, you need to be careful, especially if you want to resolder back the flash after manipulating it, since you will have small resistance and small components that can move with the heat gun. Then you use a programmer to dump the content. So there are few alternatives that you can use. You need to use the correct adapter with the correct programmer, and you can dump the content. So next we have a huge blob of binary. We run build work on the binary, and what we can observe is that this specific device is based on Qualcomm Embedded File System 2. Turns out that Binoa cannot parse nor extract AFS2 files, so this sucks. No tools available, so let's do our own. So when you want to start on this thing, you need to understand the flash layout. So how it's basically how the blocks are organized, etc. So you identify bad blocks, you remove them, you apply error correction if it's needed, and then you get the useful part of the flash. Next, you can seek for a valid partition table inside the dump. So there is a magic for that. You extract each partition to individual file, and your result is the following. So you can see on the right side, there are many partitions, and there are 2 that are based on AFS2, which is quite interesting because this is what we want. So we extract this partition to individual file, and we need to parse the file system that is on top of it. Unfortunately, there is no public information. You need to have a Qualcomm account. You need to have whatever NDA signed with them. But we found some leaked Qualcomm source code on the internet. Somebody did some backup, which is quite convenient. And then you need to understand the structure. So basically you look for superblocks. Then you use the most recent superblock. You iterate over the page table that is referenced in this superblock, and you parse all the inodes, and you reconstruct the DB tree. And at the end, you can get your files back from it. So here is a little demo. Here I provide the binary. So the flash binary. Inside I put the correct layout, and we can see that all the partitions were extracted to a single file. And then we use the EFS2 files partition and extract it. So reconstruct the directories and extract it to a zip file. This is available on the GitHub repository at the bottom of the slide. So if you want to have a look or improve the tool, it's working for files and directories, but there are many corner cases maybe that still need to be investigated. There are other ways to dump the content of the module. You remember the USB port on the side of the PCB. So if you connect it to a computer, basically what you will see is a known interface. If you search for the correct drivers, then you will end up with those three interfaces. So there is the modem, which can accept AT command, standard one. You have NMEA for getting the GPS data out of the module, and you have a diagnostic port. If you use tools such as QPST or Cocktail FS Explorer, you can get the files. However, you can see on the right side, there is some interdiction sign on the EFS private on the top. So you won't get the files that are in there or are hidden inside the file system. This is why the first version is maybe more convenient, because if you want to start digging or modifying some part of the file system that is not public, then you can do it. In the end, we end up with those main files. I didn't list all of them, but those main files. So we have a custom.bin. It's basically probably custom application binary. We have om path.ini, which is basically a text file which points to the custom.bin. And then we have q.bin, which I think it's a temporary storage for pending messages, for instance. And you have some configuration for the default and user configuration, what I guess at this stage. So if we look, the binary format is not something that is it is really known. We know it's by looking later on the file that there are some ARM instruction. So okay, but we don't know how to load it or how to start properly to analyze it. So we need to understand what type of binary it is. So we turn bin wall can have the starter banner, which can help. And this is what we see. So we see that the device might be based on something called FredX, Express Logic. So let's Google that and see what it is. So we find out that, in fact, FredX is a real-time operating system designed for embedded systems. It was known previously as Express Logic, was bought by Microsoft in 2019, and was rebranded to Azure RTOS FredX. Nice. This RTOS supports two modes. There is the command mode, so standard RTOS, with thread management, synchronization, etc., etc. And there is another mode, which is more interesting, which allows you to load and unload modules on the fly. So what it is, those modules, is basically you have a kernel extension which allows you to load and start each modules that you will put. So each module then has its own memory area, and every interaction with the kernel, such as opening a socket or doing other things, is done through predefined requests via a dispatch function, and it's quite not easy to understand at first. So if we look the module's preamble, it says, or the documentation says, that the module needs to define its own entry function, its own memory area, its stack size, and the priority of the thread that will be launched. So if we analyze the complete header, this is what we end up with. So we have a magic, we have some entry functions, and the one which is the main one of our module is the one in green, which I named Wildcat because the product is named Wildcat. And on the bottom, you can see in orange the various address and length, which will allow you to reconstruct the memory mapping for this specific type of binary. So I did a small Python loader script where you need to just to point the file that you want to load, and then you can start reverse engineering the whole binary. And here you can see on the screenshot, there is the starter banner that we saw before. So we can see Wildcat, we can see takes, thread, create, etc. So you can start reversing the whole binary from this point. You can also use a function ID database, which is quite convenient to identify some functions, predefined functions. I did it by compiling all the example in the Kektel SDK or Kek Open, which is an alternative available on the GitHub repository. So now that we have the module analyzed, we can know pretty much what's going on the startup. So we look each of the message and we start looking what's going on in the startup routine. So we can see I listed just the interesting one. You have a prolog, and the prolog is only initializing some memory. It's also configuring some LEDs, GPIOs, and starts something interesting is the known as a ATIC command handler, which is acronym is ATC, on a UART interface. And this UART interface is the same as the one that we see on the right side. Quite interesting. And then if we go deeper, we see that there is a mnt init function, which loads the configuration files, which we didn't have a look on yet, and send their content over this UART interface. And then, when the program is loaded, we can see that it waits for the network to be registered and starts some UDP socket in listening mode, as well as reading the SMS contents and injecting it to the ATIC command handler. So, if we look at the configuration file, we can see that it's the commands that were listed in the user manual, which are the extend command for the device. So, on the right side, we can see the IP address, which the device will send his event to, and some other things. This is all stored in a huge structure in the binary. But it's useful to get the list of supported commands since all the commands are defined in the program. So here just an example. On the left side you have the command which is in that. We will see later what it is. But the corresponding function will list some information about the device such as SMS, out, in, spam, etc., etc. After Googling a while, I found other documents, and this is why it's important to not only have a look on the model, the specific model that you are looking at, but also to look at the manufacturer, because you can find some useful information. And for instance, for this specific device, I found another document which had many commands documented. So it was the same look and feel, the same user manual, but with more information in it. So it's quite convenient because right now, instead of reversing the whole thing, I can just have a look and have a quick description of the function. So I listed several of them. We can see there is a function that allows, for instance, to retrieve information, but there are also other commands that allows you to debug, change the debug level, or trigger a report, so the device will send the report back to the server. So when we tried this on the interface that we think that might be good, we can see that if we send normal ATIC command, for instance for the modem interface, it will work right away, no worries. But if we attempt to send extended command, we end up with an error. However, if you do it on the application interface, so the other UART that I mentioned before, we can see that the device answers. So if we send AT, it will send out OK with its serial number. If we put AT plus XIP, which is the IP of the server, we get back the server IP address and the port number, and the serial number and the command that was passed. So it's good. From a hardware point of view, there is no security controls, no mitigation, nothing. So it's good, but it's still limited to one device. I have only one single device, and I cannot do much without opening a car at someone's location, and maybe I'm lucky and there is this same tracker, and I can do something cool with it, like replacing the firmware or changing some configuration settings. So now the question is, would it be possible to do something remotely? So for this, at work we have a base station that is able to handle 4G network. We connect the tracker to this controlled base station, and we will attempt to see if we can identify the UDP sockets that are open at startup. For this, we need to change the debug level to the correct one. So by reverse engineer, you can see that it's 80 plus X dbg 16, and we will start scanning the target device with a simple bash one-liner, which will just send the ports to the device so that I can know which port is actually open, because since it's UDP, there is no session, so I cannot know if the device received the packet or not. And this is what it looks like. So it seems like there is at least 3 different ports listening for some reasons. We can see as well that the network IP address is not the one that I had. This is the IP address that is hard-coded in the configuration file, and that the device thinks that the remote server sends a command to him. So if we attempt to send an ET command instead of the port number, we can see that the device will answer to us. So this means that I can send arbitrary AT extended command as well on this port locally. If I am on the same network as the device, it's pretty good. We can reconfigure the device, we can change settings, etc. However, it's quite annoying because since the device is behind a NAT, basically, you cannot access it easily. It's like your router at home or your PC at home, you cannot access it from remote unless you open a port or something. Here it's the same case. Plus there are some other things that should be taken in consideration, like the device can be in a specific APN, so it's like I would say the VLAN of the network, I would say, on a mobile. There can be network isolation between devices. There can be other mechanisms in place, and especially you cannot spoof UDP. It's not something that you can do easily on the internet. So the question is how to scale the attack to more devices. So we can use SMS, as we could see before. So let's try to send an SMS and identify potential targets. So first we need to identify the phone number. This is quite easily to do. We have a modem interface. So we just send this command and we get the phone number. For those who are not very confident with this, you can also insert the SIM card in your phone and you will get the number as well. So I made an assumption that providers tends to allocate the phone numbers in continuous range because there is a lot of device. So my assumption was to think that each number was assigned sequentially or in the same range. So I decided to query surrounding phone numbers. And when I did that, I got some answers, like we can see on the right, which was not from my device. And for this, I used Twilo then to automate a little bit more the things, which Twilo is a platform that allows you to send SMS. It's useful for marketing, MFA, and other things. And what is pretty convenient is that I can get a US number as well. So this is what I did. I got a good success rate of 65%. And I have to warn you because you need to aggressively rate limit if you do such things because you will get in trouble. So I got a notification from Twilo that I got a little bit too far and they suspended my account. So I was not doing something very, let's say, not good. So I was just trying to automate the things a little bit more easily, and I lost the game. So now we see that we received the same command back as before, but via SMS. So now the question is that will it work with extended command as well? And it turns out that yes. So you can query. You can see the commands that I listed before, like the xin date. which you can get some data out of the device. And you can also query for its local IP, which could be used for, if you gain access to this network, at least you can know if it's the same device you are targeting or things like that. What's fun is that there is a specific command as well to track people remotely via SMS. So you can query the device location. So I did the exercise by sending one message, and 5 minutes after I sent another message. And I mapped it on Google Maps so that you can see easily where it goes. It's fun, but it's noisy, and I got already some problem with Twilio, so I don't want to do more on this aspect. So I had a look on the IP network traffic. Since we can change the configuration by SMS, it's still a valid use case because you can send an SMS, reconfigure the device, and you can basically change the IP server to which the device will send the data. So I did it on my own device, to be clear. Don't want to get in trouble. And I just implemented the simple Python script, which will relay the communication back to the real server. And if the server sends back something, but it will be routed again to the device as well. And no surprise again. No encryption, no authentication, no nothing. So basically the payload is simply a UDP communication with raw hex bytes, let's say. And by querying or monitoring for a few packets, you can easily understand what field is which, basically. So I end up by parsing my own. So I can retrieve those information, such as the latitude, longitude, speed, heading, lock, satellite, whatever you want. You need to understand the format, and since we have the binary, we can also go back to the reverse engineering and start understanding. But this was done purely on looking the packets that were transitioning on the network. There is also some things is that the server sends back an acknowledgement to the device when he receives a report or a command. And this is a simple format. It depends on the request that you sent, depending if the frame is odd or even, and you will have one or the other, basically. So I did some investigation on what could be the data that I can get if I monitor myself for a week or two. And it turns out that it's quite simple. You can see that I'm living in QG in the Lausanne area, and that I'm doing some hockey. If you want to see the hobbies where I'm going, so on the sides here, you will see that it's mainly ice hole. So imagine doing that for thousands of people. You just need to send one SMS to one device, and you will get the data of plenty of people, basically. What is also interesting is that you can fake the tracker position, since all the traffic is UDP and the format can be understood. Then I can send back to the real server all the time the same position, and the car basically won't move. Since the packet is only authenticated, I would say, by the EMEA that the device is sending, then you can fake as well a tracker that doesn't go through your infrastructure. What prevents, however, to do that is the sequence, which is a 2-byte value. So you need to be at a higher value than the device, and then sends the events always before the device sends its own. So it's quite useful because you can then trigger false alerts, prevent the car recovery. And what I found out lately is that after the transmission, the device will wait for the hack for a certain amount of time. And it turns out that it accepts as well 80 commands. So it means that you can reconfigure, if you are in the man in the middle position, you can as well reconfigure the device through this channel. So all it takes is one SMS to do that, which is quite convenient. The last use case that I have, which I talked about earlier, is the financing. If the garage is also financing your car, Spirant proposed such solution. And you can see it's clearly written that they want to maintain prompt payments and quickly recover a vehicle when needed. So how they do that? Because they have probably the data to know where the car is, but how they can basically recover the car, they will chase you, what will happen? So it turns out that whenever they install such device for this specific product, they will add some relay. So you can see that on the right, between the key and the starter, you will need to cut the wire, put it on the relay, and then you drive the relay with a simple GPIO. And this turns out to be configurable remotely as well. So via any means that I showed before, but SMS is also fine. So I will demonstrate quickly how it works. I did a small video. So here, the relay is not present. I replaced it by a LED, which is on the left. And you can see on the right side, the Android screen where I sent a message. So first I query the status of the relay. The device answers me, so the relay is not active. And then I will enable the relay, and the LED will lighten up. So this means basically that I can prevent a car from starting remotely by using a single SMS. The only things that is missing in this whole research is that I cannot know basically which car I'm attacking. So this is why maybe we should do more research on the backend side. But I did some investigation, and it looks like it was properly done so far. So conclusion, because we are good guys, we did a responsible disclosure to the company. And since they didn't have any security contact, we sent a bunch of emails to the C-levels. Turns out it was really difficult because first I sent a Word document or a link and they complain about the format. So I needed to resend the document differently a few times. And at some points they, later on, they introduce a security contact for us. And if you look at the LinkedIn profile, you can see that he was hired the same month. So I don't know if there is some coincidence there, but well, okay. So in August, after asking many times to have a meeting with them, and they were in trouble getting emails back to us. It was really difficult for them to get emails back. That's what they said. It's not my word. We got contact with this cybersecurity manager, and from this date, we didn't have any contact anymore with them. So I don't know what they did. We did a public disclosure after the embargo, 3 months embargo, and we even extended 1 month more, if I remember well. And now we are speaking about it in Insomniac. So I wanted just to highlight some of the impacts because this is quite interesting. While doing this research, I have only one device from this manufacturer. But when you look at the reverse engineering, the binary, you have plenty of versions that are available. And if you look at the user manual or you go back to FCCID, you can see that those guys have various models. So they have Lioness, Jaguar, Jaguar H, Jaguar L, Bobcat, all the Simba, even Simba, yeah. So Puma, they have all the cat of the world. So you can choose your own, choose what you want. But it looks like the device is pretty much the same from a hardware perspective. So the firmware should be the same as well. And from this point, I make an assumption. What I can tell is that it's not limited to Spyron, so to this specific company, since the firmware is reused among many other devices. So if you want to take a look, you can take a look. In the end, the choice is yours if you want to track your car, but just make sure that the device is secured and that the device corresponds to your need. And I saw many times while doing this research that people were complaining because they buy a second-hand car and find out that there is some device left in the car, and they were really pissed off. So be careful, and just to know that it can be done in your car as well. There was some work that was done previously on this topic, on such devices. There was in Black Hat US Baidu Security Lab that did some research on the modem part. Later at DEF CON, one guy presented a system, the EVO 1, on which he spent very much time customizing the hardware because he wanted to do specific things. He ended up analyzing the whole firmware because there was two devices, so there was kind of the tracker and kind of another box, let's say, and he reversed engineered all the traffic that was going through both boxes and ended up injecting all the backend with the SQL injection as well. So I hope this talk will bring some light on some things that were not covered in those specific talk. And that's all for me for today.
Thank you very much. If you have some questions, please raise your hand so I can give you the microphone. Thanks.
Thanks for the nice talk. I have a little question. Do you know if there is some update, even if you have only one device and you didn't have news from the vendor? Do you know if there is some update, and will you continue to work on this vendor?
This is a good question. I thought that I would see an update. It turns out I didn't see any updates. So I don't know if it's because I'm in Switzerland or something like this. I'm not in the good network. I don't know what is the reason, because those trackers are US based, so I cannot tell. Hopefully there is some updates. If not, I'm sorry for them. And I will probably continue a little bit because there are some good things to dig. And I think those things can also be applied to different devices, such as routers or 4G modem USB keys that embed quite the same system from a chipset perspective. So, yeah.
Will you continue to search for some other vendors too?
I don't know, because I did this research most of the time at work. In the context of work, I would say. I had some device in hands. This is why I can tell it's not only for them, basically. But, yes, if I can have many trackers, I will continue because it's quite interesting.
Thanks.
Thanks for your presentation. It was very interesting. Are you aware about the tracker they want to have in Europe? There is a new regulation for such tracker in Europe in July this year.
No, I don't know.
Because this is in the US, but the new cars produced in Europe, we have the same box inside the car.
Okay.
So did you compare other, let's say, tracker in Europe?
No. In fact, I didn't decide even the tracker that I have in hand. Somebody come at work and just throw the device on my desk, and then magic happens. So I cannot know. But if I have, let's say, time, I will have a look. Yeah, indeed.
All right. Any other question? Okay, so we have a little bit of time before the next talk, so if you want to guys have a quick break. Yeah.
Thank you.